Welcome back, everyone. So in this video, we're going to continue this calculus exercise derivatives part 2. All right. So without further ado, let's begin. So in this first problem, we are asked to find the derivative of the cube of x squared plus 4x plus 1. All right. So we have a given of cube of the trinomial. All right. So the first thing that we come into our mind is that expansion, right? So once we expand this cube of trinomial, then derive each of the terms, then we're good to go, all right? That would be our final answer, okay? But there's another method that I can use, all right? So in the previous video, I told you that you can either expand this one or you can what? Do chain rule, all right? So for example, if I have, what do you call this one? 2x plus 1 squared, right? Is an example. So obviously, right, we're going to expand this one, then we're going to derive it, and that's it. But I can use chain rule here instead of like deriving these square of binomial as a whole, right? So I would rather just get the what? The derivative of it by applying chain rule, all right? So if I'm going to apply the derivative of hold on, there you go, 2x plus 1 squared. So obviously what I just did here is what? Basically I substitute the inner part as u, all right? Because the whole point of chain rule is derive the outer, then derive the inner. So the inner part is your what? 2x plus 1. And the derivative of your u is just 2. Because if you're going to derive 2x only, like a coefficient, a number, and a variable, will no, which exponent is raised to 1, so just remove the variable. Then we have the constant here. So if we're going to derive a constant term, that would be always equals to 0. So that's it. So yeah, this would be as the same as the derivative of u squared. All right. So by deriving it, okay, if you recall, by deriving the wait, let me rewrite this one. U raised to 2. So again, bring down the exponent, copy the variable, and subtract its exponent by 1, multiply by the du. Don't forget the partner of it. So of course you have 2u times du. And we're going to substitute this one, and this would be like 2 times 2x plus 1 times 2, right? And that's it, all right? So that's the whole purpose of chain rule. We can do that here, right? We can do that here, all right? So let's get the inner part. The inner part here, let it be u, which is your trinomial, x squared plus 4x plus 1. And now let's get the derivative of your u, all right, which is in here in this case, we're going to bring down the exponent, copy the variable, and subtract its exponent by 1 plus, since you have 4 and x only, so just going to remove the x and just get the 4. And then here for the constant term, again, the derivative of constant term is 0. Therefore, we have 2x plus 4. All right. So since u is your trinomial, so this would be rewritten as the derivative of u cubed or u raised to 3. So let's derive the u raised to 3. So bring down the exponent, copy the variable, and then subtract the exponent by 1 times your du. That's it. And now let's further simplify this one further. So you have 3 times u squared times du. All right. Now let's substitute. So we have 3 times x squared plus 4x plus 1 squared times your du, which is 2x plus 4. That's it. All right. Let me rewrite this one as 2. There we go. All right. I can move this binomial here. So we have 3 times 2x plus 4 and then times x squared plus 4x plus 1 squared. There we go. So in this case, this could be your final answer. Could be. And you know why I say could be? Because I can simplify this one furthermore. All right, I can. So as you observe this binomial 2x plus 4, I can factor it out by their greatest common factor. So you see, 2x and 4 are both divisible by 2 because 2x divided by 2 is x and 4 divided by 2 is 2. So therefore, I will factor this binomial into, you know, no, I will factor this binomial to 2. That's it. That's it. Sorry for the wrong grammar. So this is 3 times 2 times x plus 2. There we go. And then we have x squared plus 4x plus 1. All right, there we go. And that's it. So we have 3 times 2, 6, x plus 2, then times x squared plus 4x plus 1. And there we go, guys. That is your final answer. All right. So basically, that is chain rule. That's what I actually applied on the previous videos. Previous video I made. So, all right. So as you can see, this is what you do if you're going to apply chain rule. But there's this like in the last clip of my part one of this calculus exercise derivatives. This is last minute on wherein you can do chain rule by just doing it straightforward. No need substitution, just to do in a straightforward way as possible. Right? I can do that here. All right, we can do it in a way that we can just just go to the point instead of just substituting. So right, I have this one, a trinomial raised to a exponent 3 or to the third power. So since right, this is your inner function, right, or your inner part, and then these parentheses and then this exponent is the outer part. So right, I told you the goal of chain rule is derive the outer, then the inner, then multiply them both, right? So let's derive the outer part, which is your parenthesis, which is raised to 3. So since the outer part here is just an exponent of 3, right? Yeah, parenthesis raised to 3. So do the power rule. All right, so I'll bring down the exponent, copy the given, x squared plus 4x plus 1 raised to, all right, subtract its exponent by 1 times now the derivative of the inner part, which is, okay, 2x plus 4. And there you go. See, that's a straightforward way if you're going to do it. Right now, the way how I did it is just slowly as possible. All right, next. Here we have the second problem, which is sine squared x plus cosine squared x. All right, so if you're going to do this one in a way that you're not going to use other applications in trigonometry and such, all right, then let me give you some recap or recall. All right, so I have a derivative of sine x, and once you find the derivative of sine x, this is cosine x. All right, next, if you're going to find the derivative of your cosine x, this is negative sine x. That's it. All right, don't forget this one. I just recall these concepts. So let's do it in a way that we're not going to use other applications except in calculus only. Let's try that. So if ever you see this one, this is rewritten as the derivative of sine of x raised to 2 plus cosine of x raised to 2. That's it. All right. However, how can you derive this one? There's already an inner function, especially for the cosine here. So how are you going to derive this one, right? How can you do that one? So we're going to use chain rule, all right? You can just simply derive this one, all right? Or what you can do here is just basically separate them both, right? I can rewrite this one as the, sine x times sine x plus cosine x times cosine x. You can do this one, no problem at all. But what you're going to do here, if you have these two terms, you're going to do what? Product rule. So it could be what? Time consuming. So here, since you have an exponent outside, then inside of that is a trigonometric function. So therefore, what you're going to use is chain rule because there's a function inside. All right. So, all right, I will let u be sine x. All right, and then du be cosine x because the derivative of sine x is cosine x. Then your v is cosine x. Then the derivative of your v is what? Negative sine x. All right. So I can rewrite this one as the derivative of u squared plus v squared. I use v to avoid confusion or conflict on substituting via letters. Basically, I use different letters. So let's derive your u. So this would be the derivative of u squared is, bring down the exponent, copy the variable, then the exponent above subtracted by 1 times du, all right, plus, okay, for the v, the same thing, bring down the exponent, copy the variable, subtract the exponent by 1 times dv. All right, so this is 2u times du plus 2v times dv. All right, so let's substitute. Your u here is your sine x. So this is 2 times sine x. Then your du is cosine x plus 2 times your v, which is your cosine x, times your dv, which is negative sine x. All right, so this one is 2 times sine x times cosine x minus, since we have negative sine x, this would be negative 2 times cosine x times sine x. All right, since, look at this one, you have 2 and 2, sine and sine, cosine and cosine. Two of these terms have similarities, but the main difference is the sign. So despite the, how do you call this one? Despite the arrangement of sine and cosine, it's still the same. So therefore, this is just what? The same terms, but in terms of signs, no, they're not. Therefore, cancel out and you will have 0. All right. So that's the first method if you're going to do it manually. But for me, I'm not gonna do that. All right. What I'm going to do instead is application of trigonometry. We call that sine squared x plus cosine squared x is equal to 1. All right. So since sine squared x plus cosine squared x is equals to 1, therefore I can substitute this one, this expression given as the derivative of 1. That's it. So if you're going to derive a constant term, this is just 0. Easy, right? So my advice for you is, as much as possible, all right, you should at least have the knowledge of basic mathematics, right? Especially in trigonometry, because this would be very, very useful. All right. So next, this one as well. All right. So as you can see, this is so long. It is intimidating, but for me it isn't. All right. So in this case, I know what we're going to do here is very long because you have two terms. All right, so two terms, the first term and your second term. And each of the term have two subterms. There you go. And yeah, they're both combined. So obviously, what you're going to do on both of these terms, or each of them, is product rule. All right, because you have two terms, two functions combined. So yeah, that's it. All right. But not only that you're going to do product rule, but also since they have their own inputs, which is your 4x and 3x, all right, we're going to do chain rule afterwards. So yeah, you can use product rule, all right, then do chain rule, then simplify it even further. But for me, again, because I would rather do the simplest way, all right? So you see, I will let A be 4x and B as 3x. All right, there you go. So cosine B plus cosine A times sine B, it is this the same as sine of A plus B. Yeah. So you see, this is a sum and difference identities in trigonometry. So I told you already in the, what do you call this one? In the previous question that we answered, you should know this identity so that it will be much simpler for you. All right. Yes, you can do the first method that we just assume that we're going to use product rule. We just, yes, it is still correct. No problem. All right. As long as you follow the correct ways and how you derive it, it is okay. All right. But it would be more convenient if you knew the basic things or lessons in mathematics, especially in trigonometry. All right. So let's go back to the topic. Since I already, basically write the formula of sine 4x, cosine 3x, blah, blah, blah. All right. So since I have that formula earlier, then I can rewrite this one. Wait, hold on. This is wrong. Wait, there you go. Therefore, I can rewrite this one as sine of, wait, the derivative of sine of your A, which is your 4x, plus B, which is your 3x. That's it. All right. So since 4x and 3x are just similar in a way because of their variables, so we're going to add them. So we have sine of 7x. That's it. See, simple. From two terms into one simple term. That's it. So now, as you can see, we have different term here or function here inside of a trigonometric function. So you see, if it's just a sine x, that would be just a sine x. But this is different from, sine of 2x, all right? It is different from sine of x squared. It is different from sine of x minus 1, and etc. Right? This is different. You see? So these inputs are like another function or term inside of your trigonometric function, which is your sine function. So it's like, yeah, it's like sine of g of x, another function. All right. Therefore, we're going to use chain rule. Okay. So let me erase this one. Hold on, hold on, hold on. There you go. That's it. So I will let u be 7x. And the derivative of your 7x or your u is just 7, because I already told you that if you have, again, a given term, you have a number and a variable, which its exponent is equals to 1, so just remove the variable itself. That's it. All right. So since u is equals to 7x, is equal to 7x, I mean. So this is what? Sine of u. See? Now, let's go derive sine of u. So what's the derivative of sine of u? This is, again, if you recall earlier in the previous question we answered, this is cosine u. Then after you derive, don't forget your du. So now let's substitute. Cosine of your u is 7x times 7. So this is equals to 7 times cosine of 7x. That's it. That's it. All right. But if you want to do it in a way that is straightforward as possible, just like in the previous question, yes, you can still do it, right? You have sine of 7x. So again, what's the summarized steps on finding the chain rule? Derive the outer, then the inner part. So the outer part here is sine x. Then the derivative inside, I'm sorry, then we're going to find the inner part of it by getting the derivative. Again, all right, derive or find the derivative of the outer part, then get the derivative of the inner part. So what is the derivative of the outer part? Or what is the derivative of sine, which is cosine, then copy the input, then times the derivative of the inner part, 7. That's it, right? It is simple, all right? That's it. Again, the summarized steps of getting the chain rule is just derive the outer, then the inner, and combine them both. That's it, right? That's it. So next, this one. All right, this one again is intimidating because you have your first function, or let's just say expression given, and then you have another term given. So basically it looks like this one, if you want to know. This is cosine 15, okay, times cosine 30. Oops, hold on. 30 minus sine 15, then sine 30. Or see? And then you have sine squared on the outside. So meaning, yeah, you have two terms combined, right? So we have your first and your second, all right? And then inside of this first term, you have your subterms. Or to be honest, I think I'll not call this as a term anymore. Rather, this is already an expression, but expression is what? The whole, as a whole already. So maybe I'm going to say this is the simplified expression of the given trigonometric expression. All right. So since this is like, a separation from this whole given expression, which is your cosine and your sine squared x. So obviously this is what? An application of product rule. Well, yes, it is. Okay, it is an application of product rule, especially if you're going to, find the derivative of this whole and then this one. Yeah, you're going to do that. However, let me do it in simple way as possible. All right, because you see this cosine 1530 and then sine 1530. Okay, it reminds me of a sum and difference identities in trigonometry, right? We introduce ourselves the sign of a plus a plus b. All right, we have also for cosine. So I will let b 15 as a and b as 30. So I have cosine a times cosine b, minus sine a times sine b. So if you see this given trigonometric expression, this is equals to cosine of a plus b, right? A plus b, all right? So to rewrite it in different way, remember this one, okay? I'm just going to erase it in 3, 2, 1, go. So to rewrite it in different way, this is what? The derivative of, all right? This is, hold on, this is cosine of your A 15 plus your B 30 degrees, right? That's it. Then times sine squared of x, right? That's it. So since 15 and 30 are just similar, so yeah, just combine them. So you will have cosine of 45 degrees. I'll just put degrees, right? There you go. Then times sine squared of x. So since we have two given terms here, we can now use what? Product rule, right? Yeah, you can. But for me, I think I do not need to use product rule here. I do not need. All right. So let me finish rewriting them in a simplified version, right? We have cosine of 45 degrees and then times sine of x raised to 2, right? So obviously, in this case, you have a function within a function, all right? So you have like a square and then you have a sine. So obviously, it's just like the previous question that we answered, we're going to use what? Chain rule, right? We're going to use chain rule. Okay. So yes, chain rule. But for this one, we're not going to use, you know, product rule for this one or chain rule because this is already a constant. Yes, it is already a constant. All right. So if you're going to find the wait, let me use different tool here. I think it would be far better. All right. So if you're asked to find the derivative of, let's just say, cosine x. Okay, so this is what negative given function inside of a cosine function. So meaning I will have cosine u. So this is what chain rule, right? So this is negative sine u times du, all right? But what if the input is just a constant, all right? Cosine of c. Let c be the constant, all right? Letter c. So this is 0, all right? This is 0, okay? It is 0. So what? If you're going to use product rule or chain rule, the answer for that would be just be 0. All right, product rule and chain rule. All right, if you're going to use product rule and chain rule, this would be what? A cosine 45 degrees is 0. All right, so this is just a what? Constant. So this and this and this, they're not the same. They're not equal. Right? So hold on, let me erase this one. So do I still need to apply product rule? No need. Because right, I told you that cosine 45 degrees is constant. So instead of including them in the derivative, derivative of cosine 45 degrees times sine of x raised to 2, instead of including them both to find the derivative, and yeah, you know, cosine 45 degrees is just a constant, leave it be. Because since it is a constant, remember in constant rule, don't touch it. Don't touch the constant. Just derive the next part of it. So let's not touch this one. All right, don't touch this one. All right, so we're going to touch this. Okay, and plus, guys, if you recall your trigonometric identities, cosine 45 degrees is equal to square root of 2 over 2. So that means the derivative of cosine 45 degrees, which is your constant, this is what? Square root of 2 over 2 times, wait, sine x or sine x raised to 2. So you see? So these two are just constants. So don't touch it. Instead of using product rule and such, no need. It would be a hassle. So just leave it be. You can either use cosine 45 degrees or square root of 2 over 2. Either way, don't touch it. So let's just leave square root of 2 over 2 behind. Right? Next, now we're going to do chain rule here for what? Sine x squared. All right, hold on. So let's do it again in a slow manner. So sine x is your inner part. So I will let u be sine x. All right. Then the derivative of your sine x or your du is cosine x. So I can rewrite this one as the derivative of u squared. So let's find the derivative of u squared, bring down the exponent, copy the variable, then subtract each exponent by 1 times your du. So you have what? 2u times du. So this is 2 times sine x, all right, times cosine x. So therefore you have 2 times sine x, all right, and cosine x. All right, that's it. So you have this. By the way, you can find the derivative of sine squared straightforward, all right? Right, you can do it, okay? So you want me to try? So no problem. So sine of x raised to 2, right? You have that one. So the outer part here is what? A parenthesis and exponent of 2. And the inner part is sine x. So the first step on getting the chain rule is derive the outer part. So the outer part here is your exponent 2. So this would be what? Okay, bring down the 2, copy the given, or the input, then subtract each exponent by 1, then times the derivative of your inner part, which is your sine x. So this is cosine. That's it. So you have this one, sine x times cosine x. Okay. So I can have two answers here. I can have two answers. So I'll have my first answer. My first answer here is this one. So I'll just cancel 2 and 2 here because this is the denominator and here 2 is just a whole number, so I can cancel out. So I will have what? Square root of 2 times sine x, all right, times cosine x. This could be my final answer. It's okay if you're going to arrange it, no problem. But yeah, this is my final answer. So that's the first one, huh? This is the first one. Or before anything else, um, let me give you a short recall. Okay, let me erase the other parts here. All right. Here, I'll erase this one. So recall that 2 times sine x times cosine x is equal to sine of 2x. All right. So this is what? Double angle identities in trigonometry lesson. So you can substitute 2 times sine x times cosine x into sine of 2x. So this is what? Square root of 2 over 2 times, right? 2 times sine x times cosine x. So this is times sine of 2x. So either way, the answer is still correct. All right, that's it. Next. All right, so here in this problem, all right, we're asked to find a derivative of tangent squared of x times -1 plus secant squared of x. So it seems like we have given two functions, or rather two expressions. This tangent squared of x is just a term, yeah. And we have this another set of terms, so this is just another expression. So meaning there's like combination of two, right? So there are a lot of ways you can do it. You can basically distribute tangent squared of x to each of these terms, all right? Or you can use product rule. Just let this be like the first function or the first expression, and this one will be your second expression or your function. It could be just separate them into expressions or terms, make it them as like separable way that you can substitute each of them as u or v. Then product rule it is, right? But I'm not gonna do that. What I'm going to do instead is what? Simplification. All right. But since you're already here, let's try to recall the derivative of tangent and secant. All right. Let's find the derivative of tangent and secant. Let's have a short recall on that. All right. Oops. That's it. So the derivative of tangent x, all right, is equal to secant squared of x. Your secant, all right, is equals to secant times tangent x, all right? Don't forget this one because maybe the next part or the next video that I'm going to upload, I'm not going to recall this one. So yeah, all right, this is short recall, tangent x, secant squared x, secant, and that's it. All right, okay. So if you're gonna do it manually, like just gonna distribute it and then just get the answer, no problem, all right? There's no problem with that. But for me, I'll do it in a simple way. Right? I have the what I call as the what's that again? Pythagorean identities. Yes, Pythagorean identities, right? I have sine squared x plus cosine squared x is equals to 1. I also have 1 plus tangent squared of x is equals to secant squared of x. Right? I have that one too. So if I transpose 1 to the other side, I will have what? Tangent squared of x is equals to -1 plus secant squared of x. And we have -1 plus secant squared of x here. right? So since -1 plus secant squared of x is equal to tangent squared of x, therefore, I can rewrite this one as, okay, the derivative of tangent squared of x times tangent squared of x. There you go, right? And then now take a look. They have the same base, tangent and tangent, and then they have the same exponents, all right? So there's this what you call, the rules of exponents. So for example, if you have x raised to 2 times x raised to y, you have the same base. You have different exponents. So just copy the base and then add the exponents. All right, that's it. All right. So let's just say I have x squared times x squared. So the same base, the same exponent. So just copy the base and add the exponents. So you see, as you can see, whether the exponents are different or the same, all right, despite that their base are the same, you're going to add them both, all right? So in application to this one, we're just going to what? Copy tangent and then add the exponents. So 2 and 2. So 2 plus 2 is 4. That's it. And I can rewrite this one as the derivative of, hold on, of tangent of x raised to 4. There you go. All right. So again, this is just as similar as the sine squared of x, right? So since you have a given trigonometric function inside of or maybe of an exponent, so of course what we're going to do here is what we call as the chain rule, right? Chain rule. So the inner part here will be your u. So let u be tangent x. All right. Then the derivative of your tangent, if you recall, this is secant squared of x. All right. You remember this one, secant squared of x. All right. So this is already the derivative of u raised to 4. So, all right, since this is already the application of power rule, so let's bring down the exponent, copy the variable, then subtract its exponent by 1 times your du. So let's further sorry, let's further simplify them. So you have 4u raised to 3 times du. So your answer here is 4 times your u is tangent x raised to 3 times du, which is your secant squared of x. So I can rewrite this one as 4 times tangent cube of x times secant squared of x. This could be my final answer because I can simplify this one furthermore. All right, so let's have a recall. So we have tangent x as an example. And if you recall trigonometric identities, tangent x is equals to sine x over cosine x. All right? For your secant, all right, your secant is equals to 1 over cosine x. So if I say I have cube of tangent, that means your right part, sine and cosine, will be raised to 3. If you have squared or secant raised to 2, therefore your cosine as well and your 1 is also raised to 2. All right? So this one is obviously 1. All right? If you're going to square 1, it's still going to be 1. All right? So that means I can rewrite this one as, let me put it here because I have more space and I want to, occupy at least everything of it. So this is 4 times sine cube of x over cosine cube of x. That's it. Times, right? Times secant squared, so this is 1 over cosine squared. So by multiplying them, so you'll have 4 times sine cube of x, and all over cosine cube of x times cosine squared of x. And guys, remember this one, right? You have tangent squared of x and tangent squared of x. So you see, they have the same base, right? You have tangent of x, and then you have an exponent. So what do, right? We add them both, the exponents, I mean. So you have tangent raised to 4. Right? That's the same thing here in cosine, all right? So since cosine, the left part, cosine cube of x, and the right part, cosine squared of x, okay, their base is just the same, all right? But the exponents is just different. So we're going to add the exponents. So this would be what? 4 sine cube of x all over cosine of 3 plus 2, 5. So this is cosine raised to 5 of x. This is your final answer. See, that's it. Next. Now we have this one. Secant of 10x squared plus cosecant of 30. All right. So obviously what we're going to do here is we're going to derive each of these terms. The secant of 10x squared, this is a term that has another function inside of it. So what we're going to do here, we're going to use chain rule because there's already a different function or term inside of a trigonometric function. Sorry. But for this one, what are we going to do here? All right. This is what? 0. All right. So why? But before that, let me find the derivative of cosecant. Before that, let me find the derivative of cosecant if you are still curious. All right. So if you're going to find a derivative of cosecant, it's just similar as the secant. However, this is somewhat different because of their terms used. So this is, okay, negative cosecant x times cotangent x. There you go. So that's it. All right. But right, I told you that, for example, I have an example of cosine 45 degrees. You know that? That's the same thing here. All right. That's the same scenario or situation happening in cosecant. So if you're asked to find the derivative of cosecant of, let's just say, no, not x. Rather, this is a constant. The input itself is not a function nor an x, but a constant c. So this is what? 0. This is just 0. All right. And plus, guys, if you'd recall, cosecant is equals to 1 over sine x. So if your input is 30, which is this 30 degrees, which is equal to 1 over sine of 30 degrees, all right? And remember that sine of 30 degrees is equal to 1/2. Therefore, this is what? 1 over 1/2. If you're going to simplify it by further reciprocation or by getting the reciprocal of it, you would have 2. All right. So meaning it is still constant. You see, it is constant. Cosine 30 degrees or 2, it is constant. So therefore, the derivative of cosine 30 degrees or the derivative of 2 is just 0. All right. So, okay. Let's go focus first in a second. All right. So I will let u be 10x squared, and the derivative of u, again, just copy the coefficient, bring down the exponent, and subtract its exponent by 1, so you'll have 20x. So you'll have what? The derivative of, right, hold on, the derivative of secant of u plus cosecant 30, which is just the same as, 2. So the derivative of secant all right, is what? Secant again. Copy the input u times tangent u, all right, times, don't forget your du. Plus, again, this is a constant, so this is 0. Now let's substitute. So this is secant of 10x squared times tangent of, oops, hold on, tangent of 10x squared times du, which is 20x. So your answer here is 20x times secant of 10x squared times tangent of 10x squared. That's it. Right, that's it. Okay. By the way, if you want to do it straightforward, yes, you still can. Yeah. All right. Right, we have, what do you call this one? Secant of 10 of x squared, right? Right, you have this one. So again, the summary steps of it is derive the outer, then the inner. What is the derivative of secant? So it's still secant, then copy the input, 10x squared, times tangent, 10x squared, right? Then now, sorry, then next is derive the inner part, which is your 10x squared. So this would be 20x. And then there, if you're going to arrange it, then that's it. See? So this could be your final answer, all right? Because this, this expression, I can simplify it further, all right? So recall that secant x is equals to 1 cosine x, 1 over cosine x. So therefore this is, wait, hold on, 120x times 1 over cosine, right? But instead of x, what you're going to have is what? 10x squared. That's it. Times tangent is sine of, right? 10x squared all over cosine of 10x squared. That's it. And now let's further combine them both. So we have actually three of them. Yeah. Let's combine the three of them. So you have cosine of sine of 10x squared. That's it. And then there you go. Cosine of 10x squared times cosine of 10x squared. And again, look at this one. Cosine 10x squared, and then we have another cosine of 10x squared. So meaning both of them are the same. The base are the same, all right? And recall that any term could be a number or variable or trigonometric term, all right, is always raised to 1. So for example, x is equals to x raised to 1. 2 is equals to 2 raised to 1. 3.1 is equals to 3.1 raised to 1. Sine x is equal to sine of 1, sine raised to 1 of x. That's it, right? So everything raised to 1. So therefore here, cosine has an exponent of 1 and 1. So therefore, we're going to combine them both. So I'll have 20 x times sine of 10x squared, okay, all over cosine, and then the exponent 1 plus 1, so this is cosine squared of 10x squared. And that's it, guys. You have your final answer, right? So you can further simplify this one more. You still can, but for me, I'll stop right here. So it's either you can use this one as your final answer, this one, or this one. Either way, they're all correct. Next, this one. So you see, all right, let me rewrite this. Wait, the derivative of, okay, hold on, sine of cosine of x, all right, raised to 2, that's it. So you see, it seems like this is a bit of a challenge because inside of a squared of a term, we have sine. And then inside of sine, we have cosine x. Again, let's take it slow. All right. Okay, inside of a parenthesis and has an exponent of 2, inside of that is the term sine of cosine x. And inside of sine, we have another term or function given inside, which is cosine x. So therefore, what we're going to do here is what? What we're going to do is what we call as the chain rule, right? Chain rule. So as you can see, all right, how do you apply chain rule here? All right. So this is kind of a bit of challenge. So let's try to do substitution. So right, your the inner part of the parentheses and exponent of 2 is sine of cosine x, right? So I will let u be sine of cosine x. All right, that's it. But then let's find the derivative of your sine. But how can you find the derivative of sine x? Or the whole part here, how can you define, how can you find the derivative of this one? So we're going to what? Do another chain rule inside. All right. To get your du, you're going to do another chain rule. So look at this one. All right. Because you have a function given inside of a trigonometric function, which is a sine function. So therefore, you're going to what? Do chain rule. So inside of sine, you will substitute what? Cosine x. Okay. Then now, all right, get the derivative of your cosine. So this is negative sine x. So meaning your u is equals to what? Sine of v. And now, okay, we have your u, we have your v. Now, how about we get the derivative of your u? So the derivative of sine of v. So what is the derivative of sine of v? So remember that the derivative of sine is cosine, right? So this is cosine v times the derivative inside, which is your dt. Okay? So before we substitute values, all right, let's do it later. Okay? Not today. Let's just do it later, first and foremost. Okay? So, all right, let's go first here. So, right, your u is sine of cosine x. So, I can rewrite this one as, whoops, hold on, the derivative of, all right, hold on, the derivative of u squared. So now let's get the derivative of u squared. So bring down the exponent, copy the variable, subtract its exponent by 1 times du. All right, so you have 2u times du. Now let's substitute the given what? Given letters. All right, so your u here is what? 2 times sine of v times your du, which is cosine v times dv. And now let's substitute. So this is what? 2 times sine of your v, which is cosine x. Oops, cosine of x. All right, times cosine. All right, then you have your v. All right, so what's your v again? It's still cosine x. Then times your dv, which is negative sine x. That's it. So now let's further combine them. Output negative sine x to the before sine of cosine x. So I'll have negative 2 times sine x times cosine. Oops. No. I'm wrong. Okay. Sine x times sine of cosine x times of cosine x. There you go. And that's your final answer. Right? That's your final answer. So can we do it as straightforward as possible? Yes, you can. No problem. To be honest, right now, I'm showing you two methods. As you observe in this video, I'm showing you two methods. First, chain rule method, but in a slow way. But the second is go direct to the point. Okay. So in this case, right, I told you the again summary steps of chain rule. Outer, inner, right? But for this one, we have another inner part. Then get the derivative inner. Okay. Basically, second order. Okay, derive the outer, then inner. Then if you have inside, then get the derivative inner. So get the derivative of the outer part, then the inner part, then the innermost part until to the last. That's it. So let's try it. All right. So right, we have sine of cosine x. All right, and you have 2. So the outer part here is your what? A parenthesis when exponent of 2. Then the inner part here is your sine of cosine x. Then the innermost part is your cosine x. So let's start with the outer part. Derive the outer part. So this is just a power rule. So this is just bring down the 2, copy the given, which is sine of, hold on, there you go. So sine of cosine x. Okay. Then subtract the exponent above by 1 times, now derive the next part, sine of cosine x. So what is the derivative of sine? Which is the inner part. This is what? Cosine of, copy the input, cosine x. Alright? Then times, now the last part, derive the innermost, which is negative sine x. Alright? So therefore you have 2, alright, 2 times sine of cosine x raised to 1, that would be just leave it be as it is, times cosine of cosine x times negative sine x. See, it's just similar as this one. That's it, guys. That's it. All right. So let's take a look to the next problem. All right, this one, how about this one? Tangent of secant x. So obviously, this one is actually the simplest one because yes, you have a trigonometric function, then inside of your input or inside of your trigonometric function rather is secant x. All right, so we're going to do chain rule here. So let's do it again slowly. All right, the inside part is your secant. So I will let you be secant x. Then the derivative of that, so we have secant x times tangent x, right? That's it. So I'll rewrite this as the derivative of tangent of u. So what is the derivative of tangent of u again? So the derivative of tangent of u is secant squared of u. Then don't forget your du. So now let's substitute. We have secant squared of, which is your u, secant squared of secant, times your du, you have secant x times tangent x. That's it, right? That's it. Okay, so this could be your final answer. Okay, or to be honest, we're not done. Okay, we can now substitute the trigonometric identities. Recall that secant is equals to 1 over cosine, right? So this one is 1 over cosine squared of, since secant, you can just copy as secant if you like, or you can rewrite this one as 1 over cosine. No problem at all. So let's rewrite this one. Then times cosine x. Oh, sorry. No. Wait. That's so random. Right? This one. 1 over cosine x. Then times sine x over cosine x. Alright. So now let's combine. So this is what? Sine x all over. Alright. We have cosine squared of 1 over cosine x all right, times, since you have the same base of cosine and cosine, so this is just cosine squared of x. That's it, and you're done. That's it. By the way, still if you're not convinced to these substitutions, then you can just do what? Straightforward chain rule. All right, so let's do it again. Tangent of secant of x. All right, so first step is derive the outer part. So what's the derivative of your tangent, which is your outer part? This is secant squared of the given input. Then second part is derive the innermost part, or the last part, which is inside of it. So this is just me secant x times tangent x. Oh, see, that's it. All right, that's good. Now we have this one. All right. So if you have two given terms, so obviously we're going to use product rule here. Sine x times cosecant x. All right, because you have two terms combined. However, actually two terms combined or two functions combined. You can just say that, right? However, I'm gonna do it in a simple way. I'm just gonna do it in a simple way. All right. So as you can see, recall that cosecant x is equals to, cosecant x is equals to 1 over sine x, right? I already recalled to you earlier. So this is just the same as sine x times 1 over sine x. If you don't know, guys, or if you want to have a short recall, cosecant x is equals to 1 over sine x, right? That's it. So now let's combine them both. So you have sine over sine. And then since they're just both the same, so this would equate to the derivative of 1. That's it. So what is the derivative of your 1 or your constant term? This is what? 0. That's it. That's your final answer. All right. But okay, guys, forgive me if I keep using the word term or what. If I can just use functions instead, right, to avoid confusion and such. All right, because if ever I see like a single term like sine x and cosecant x, instead of saying function, I'd rather just say, just say two terms combined rather than two functions combined. All right, maybe I just use functions, the word function, if ever there's another function inside of a particular function. All right, so forgive me if I use the words in the wrong way. All right, so yeah, let's go. That's it. How about this one? You have 200 sine x and cosine x. So we have a constant and you have sine x and cosine x. All right. So obviously we're going to use a product rule here. All right. So by the definition of product rule, if you recall, the formula for that is what? All right. U dv plus v du, right? So can I include 200 in U or V rather? Yes, you can. There's no problem. But for me, again, there is this constant rule of differentiation. If you have a constant and then there's a particular variables next to it or terms or trigonometric terms used, then don't touch the constants. So therefore, I'm going to leave 200 as it is. So I'm just going to say like this is 200, right, times UdV plus VdU. All right. So yeah, again, by constant rule of differentiation, if you have a constant, the next to it is a variable or trigonometric terms or other terms or functions, then don't touch it. All right. So I will let U be sine x, and I will let du be the derivative of sine x as cosine x. V will be my cosine x, and the derivative of dv is negative sine x. There you go. So you have 200 times your u, which is sine x, times your dv, which is negative sine x, times your v, which is your, plus v, which is your cosine x, times your du, which is cosine x. So that's it. So what I'm going to have here is I have 200 times negative sine squared x plus cosine squared x. And this could be my final answer. You can further simplify it. It's okay if you like to. You can apply trigonometry identities here. It's not a problem to me. All right. Or you can just distribute 200 on each of these terms. No problem. All right. Either way, it is still correct. All right. And I think that's it. We're done. So thank you again for joining me as we answer these questions in Calculus Exercise Derivatives Part 2. And again, forgive me if I keep saying the words, use terms, functions, or expressions in a confusing manner, right? Because I know that terms just basically just one, like 2x, sine x, all right? Then for expression, it would be like a combination of all terms, and that's it. So, oops, sorry. So that would be it, to be honest. Don't worry, I will continue to improve my communication of it. All right. So maybe instead of terms, I can just use functions rather. And yeah. So that's it. That's it, everyone. And thank you again for listening. And this is Math Angel Wade, and I'm always here to guide you in discovering or answering mathematics. See you.